Hello, ladies and gentlemen. So today we are going to take some notes on some absolute value functions. As you learn throughout the exploratory activity, hopefully, you were able to pick up on some of these. I'm going to give you some more formal notes now for you to use for today's class. So please follow along, take the notes. I've printed the copies for you to fill in as we go through them together. Okay, so to start, here is a picture of the parent graph of absolute value. And as you know, the equation is y equals the absolute value of x. So we're going to start off by talking about the domain, the range, and the vertex. So as you can remember from earlier when we talked about functions from the beginning of the year, we talked about domain being the x values. So I know that this graph kind of looks like it ends, but really there are arrows on the ends of these. So if you want to draw those in, and those arrows indicate that this absolute value graph does continue in both directions there. It continues both to the left, to the right, and then both of the arrows are also going up. So since there's an arrow on the left, the farthest point to the farthest to the left, I know you would probably think it would be -2, because that's all that's shown on the graph. However, this arrow means that it continues, keeps going to the left. So if I keep going to the left of this graph, this line's going to keep going. So the graph really never ends. So it starts all the way at -infinity. The domain goes from -infinity, which is less than or equal to the x value. And the positive side, going all the way on the x, the farthest point to the right, again, it's still going this way, and it's going to continue to go to the right, so that is to in positive infinity. Another way we can write it, so this is one way we could write it, and we'll put these little squigglies to show the set. But another way we could write it is with this symbol, which is called all real numbers, because it represents all the numbers on the number line from -infinity to positive infinity. So that's another way we could just write it. So it's this or this. You don't have to have both. The range is the y values. And if you can remember, the y values are going up or down. And the lowest point on my graph on this parent graph is the origin. And that means that we're starting at 0. It's less than or equal to y. And then we go up. And how high up we go, and these arrows are going to keep going up and up and up and up and up. So it goes to positive infinity. So that is one way we can write it as well. Okay, the vertex. So the point here that's called the vertex is the lowest or the highest part of our absolute value graph. In this case, it's a low part. So this is a minimum. I'm going to write minimum because it's the lowest point on our graph. If it were the highest point on our graph, if this V was actually upside down, then we would know that it wouldn't be a minimum. It would be called a maximum. Okay, so this is a minimum. And in this case, it is a point. And the point of this vertex is the point 0, 0. All right, so that's the information for domain, range, and the vertex of our parent graph. And we're going to use this idea using this equation because this is the original equation. And once we add things to it or multiply it, it's going to change the equation. So let's go on to read the next part. It says an absolute value function is a function that contains an absolute value expression. The parent absolute value function is f of x equals the absolute value of x. The graph of f of x equals absolute value of x is V-shaped and it's symmetric about the y-axis. So once I change it, however, it's no longer going to be symmetric about the y-axis if I move it to the left or I move it to the right. What will happen is it's going to be symmetric about the point of the vertex and the axis of symmetry at the vertex. So a little line, a visible line that goes through the vertex is where it's symmetrical. Okay? All right, so utilizing the graph below, we're going to evaluate the following. So now I'm going to move this down, and we're going to just continue here. So let's take a look at this graph that's over to my left. And if you look at part A, it says that f of 3 is equal to what? So let's remember that f of x is equal to y. Okay? So if I'm looking at f of 3, I'm really looking at when x is equal to 3, what is y equal to? That's really what I'm asking. If the x is equal to 3 in our graph, what is the y value on the graph? So to find this out, we go to our graph, we go to the value where x is equal to 3. So here's x equals 3, and I'm going to go up on my graph to the line of the absolute value graph. So you see, and this is where it meets it, where x is 3. So when x is equal to 3, what is the value of y? So I go over to my y-axis, and what is the value of my y there? It's 2. So when x is equal to 3 on this graph, y is equal to 2, and that's how we write it in function notation. We're going to now do the same thing for another,